And it's exactly this new realm of molecular genetics where we see the most compelling evidence of design on the Earth.
When I look at molecular machines or the incredibly complex process by which cells divide, I want to ask, is it possible that these things had an intelligence behind them, that there was a plan or a purpose to this structure? Science ought to be a search for the truth about the world. Now, we shouldn't prejudge what might be true. We shouldn't say, I don't like that explanation, so I'm going to put it to one side. Rather, when we come to a puzzle in nature, we ought to bring to that puzzle every possible cause that might explain it. One of the problems I have with evolutionary theory is it artificially rules out a kind of cause even before the evidence has a chance to speak. And the cause that's ruled out is intelligence.
Since the late 19th century, since the time of Darwin, in fact, in part because of Darwin's writing in The Origin of Species, scientists came to accept a convention, a definition of science that excluded the possibility of design as a scientific explanation. And that convention has a name. It's called methodological naturalism. And it just means that if you're going to be scientific, you must limit yourself to explanations that invoke only natural causes. You can't invoke intelligence as a cause. And yet, curiously, we make inferences to intelligence all the time. It's part of our ordinary reasoning to recognize the effects of intelligence.
Consider, for example, these hieroglyphic messages carved upon the ruins of Egyptian monuments. No one would attribute the shapes and arrangements of these symbols to natural causes like sandstorms or erosion. Instead, we recognize them as the work of ancient scribes, intelligent human agents. Similar reasoning leads us to conclude that the mysterious stone figures on the shores of Easter Island were not formed by the actions of wind and water over great periods of time. Nor do we presume that plants could grow into these familiar shapes without some manner of intelligent guidance.
Of course, we make these inferences all the time, and we know they're correct. But the question is, on what basis do we make these inferences? What are the features that enable us to recognize intelligence?
Recently, in a book titled The Design Inference, mathematician William Dembski has made an important breakthrough in understanding design reasoning. Dembski has identified the specific features of artifacts that cause us to recognize prior intelligent activity.
I came to this by trying to look at how do we reason about design? What are the logical moves that we have to go through in order to come to a conclusion of design? So what I'm trying to do is to establish reliable, empirical, scientifically rigorous criteria for deciding whether something is in fact designed. So I was looking at the logic of it. And what I found was you need improbability and you need specification, the right sort of pattern, these objective patterns.
According to Dembski, human beings correctly detect the activity of intelligence whenever they observe a highly improbable object or event that also matches a recognizable pattern. Just such a pattern is found in the Black Hills of South Dakota.
If you travel through the West, you'll see lots of different shapes on mountainsides, most of which mean nothing at all. They're just rocks strewn in various patterns. But what you don't see are the faces of Lincoln, Jefferson, Teddy Roosevelt, and George Washington on mountainsides. The only place you see that is in South Dakota. And the reason it's there is because a sculptor, an eccentric sculptor, decided that he wanted to honor these presidents by spending the larger part of his life chiseling their faces in the side of that mountain. That pattern is improbable. A random hillside is also improbable, but a random hillside doesn't specify anything. We do know, though, that there were 4 guys who were presidents of the United States who had particular patterns with their faces, and those patterns on the mountainside in South Dakota match faces elsewhere.
If I look up and see the faces, I immediately recognize that they match the faces of the 4 presidents that are known from money or portraits at the National Gallery or paintings and books. And so I realized when I look at Mount Rushmore, we have not only a highly improbable configuration of rock, but one which matches an independently given pattern that reliably indicates intelligence.
So we have a small probability, specification, its design.
On a seashore, another improbable pattern etched into the earth illustrates how we detect design. No one would infer that this message was written by the movement of the tides. Instead, because of the characteristics of this pattern, we identify the words as the products of intelligence.
That improbable arrangement also conforms to an independently given pattern, namely the shapes of the letters that we recognize from English alphabet and the words that we know from English vocabulary. And so it's the improbability of the arrangement plus the fact that it conforms to an independently given pattern that triggers the awareness of design.
This illustration suggests that William Dembski's criteria for design detection, small probability and specification, are essentially equivalent to information. The type of information present not only in pictures, written texts, and numeric sequences, but also encoded in software and radio signals. The ability to detect information in electromagnetic transmissions has made possible a unique search for intelligence. For more than 3 decades, astronomers involved in SETI, the search for extraterrestrial intelligence, have monitored radio signals from outer space in an attempt to find information-rich patterns. Typically, radio telescopes receive either random noise or simple repetitive signals produced naturally by stars, galaxies, and other celestial objects. But astronomers recognized that if they ever identified an information-bearing signal, it would confirm the existence of intelligent life beyond the Earth. Some have speculated that an extraterrestrial civilization might have attempted to communicate by transmitting messages in the universal language of mathematics, perhaps through a recognizable pattern, like a series of prime numbers.
You're not going to get that by chance. So you need complexity or improbability, lots of prime numbers, and you also need a pattern. And it has to be the right sort of pattern. It's not a pattern that you're imposing. It's a pattern that's there objectively.
To date, SETI research has failed to detect any pattern or information that would indicate intelligence in a distant galaxy. But in another universe, much closer to home, scientists have discovered a wealth of information within the nucleus of the living cell.
DNA has a structure that is ideal for carrying information. In the A's, T's, C's, and G's, the bases of the double helix of DNA, is the potential for storing a tremendous amount of information.
There is, in fact, no entity in the known universe that stores and processes more information more efficiently than the DNA molecule. A full complement of human DNA has 3 billion individual characters. Analysis of the DNA molecule's coding regions show that its chemical characters have a specific arrangement that allows them to convey detailed instructions or information, much like letters in a meaningful sentence or binary digits in a computer code.
Bill Gates has said that DNA is like a computer program, only much more complex than any we've been able to devise. And if you reflect on that even for a minute, it's a highly suggestive observation, because we know that Bill Gates does not employ wind and erosion or random number generators to generate his software. Instead, he employs intelligent engineers, software engineers. And so everything we know in our experience suggests that information-rich systems arise from intelligent design. But what do we make of the fact that